This week we're going to be talking about digitizing and georeferencing in two separate videos as part of this third section of material. And we're really going to cover just a few specific things. What is digitizing? What is georeferencing? We'll talk about some sources of spatial data. So how are we starting to work with spatial data? How are we developing spatial data? And this week, you're really going to learn about the process of digitizing, which is creating shape files like points, lines, and polygons based upon those sources of spatial data. So as usual, there are the learning objectives each section that we go through. I won't read through all these, but please make sure that you're kind of checking those and thinking about what I'm asking for in these learning objectives as you read through the notes and watch these videos. So this week we're talking about digitizing, and this is something you're going to be doing in the lab. And basically what we're talking about is taking some type of image or some type of map out there and then manually going in and digitizing or creating spatial data. In this case, you'll be creating lots of different types of vector data, so shape files and ArcMap. So you'll create points or lines or polygons onto some type of image or map to create those datas into a GIS data set. And it's kind of as you imagine, we'll talk more about it, but it's literally kind of like drawing in there. So there's a lot of sort of zooming into the map and figuring out what you want to digitize. Trying to make sure that the digitizing process is as accurate as possible. Before we get into the actual process of digitizing, and then in the next video, georeferencing, I just want to start by really talking about some of the more common sources of where we might first work with GIS data or develop GIS data from. And so we have things like, you can imagine basically taking an old hard copy map, or an old image, some type of old aerial photograph that might be a hard copy as well, and potentially having to, scan that information into a computer system to use. We also might have sources that are already digital. So there are digital maps. We'll talk about digital raster graphics, but there's other options as well. Some maps that have already been scanned into a computer system. We'll use other types of data as well, like different types of remotely sensed data. So not just aerial photographs, like I mentioned already, but of course satellite imagery is a really important aspect of, an original source of GIS data. But then there's also things you might have thought about before, like, collecting data in the field with a GPS unit. A lot of cases that might just be data you've collected with your smartphone these days. But if you really want good, accurate information, and we'll talk more about GPS later on, there's different options for getting very accurate GPS information with the right type of GPS unit that you're using. And then the other option, which we'll really start working with in the next few labs, is starting to create tabular data. So those attribute tables behind, say, vector data, you can go in and enter the information that you want in there. So once you have some type of spatial data, you can create new data in the attribute table, depending on the type of project you're working on or the information you want to know about spatially. And so just to look at a couple common sources, some things to kind of think about here. If you have a hard copy map or some type of old aerial photo, obviously these would be hard copies, so they're not in a computer system yet. And what that means is you have to first scan them into a computer. And of course, when they're scanned in, there's not going to be any type of spatial information in the computer about it. And that's a really important topic that we'll talk in the next video about. When there's not spatial information, we have to then do something called georeferencing that digital image that was scanned into the computer. Now, there are also things like digital raster graphics, sort of maps that are already digital that you can find out in different sources through like USGS or other types of organizations, and other types of maps, not just DRGs, these digital raster graphics. Now, a lot of times these days when you find digital maps, they already have spatial information. And of course, they don't need scanned into a computer. These are already digital. You might find them on some website, download them. Sometimes they don't have spatial information. So then we have to think about that process of georeferencing, which we'll talk about later on. Now, the other big one, of course, like I mentioned, is, different types of remote sensing technology. And so I won't spend a lot of time talking about remote sensing right now because we talk about that later on in the course. But I do just want to mention, two common sources would be aerial imagery. So I'll show some examples of using aerial imagery as sort of a base to start with with creating GIS data. And then, of course, satellite data. So in this example, here's a satellite image that I've used in my previous research. You can see here, this is in basically a false color. So anything in the red is sort of showing what would be more like vegetation. These other areas, a little close up of this box here is Richmond, Virginia. You can see the city of Richmond right here with the James River flowing through, and this is the Chesapeake Bay watershed. So satellite imagery is a very important tool that can be used that initially comes as raster data. But remember, we can use these images just like an image or something else to do that manual digitizing. And so you'll see this, and this is a pretty good way to kind of think about, your starting point. If you have some type of hard copy map or image, the first thing you're always going to have to do is scan it. You have to get it into a computer system. So you'll scan that image in, just like you would if you had like a hard copy photograph that you were trying to get into a digital, image. So you have to scan that in, and then, you'll have to georeference. Basically, what that means, and we'll talk about it later on, is registering some type of spatial information to that image so that you can use it spatially. So it'll have to go through that georeferencing process. Now, if you have a digital map or image, it might already be georeferenced, and you can kind of move on to these steps down here. If it does not, then you have to georeference. And then basically, once you have a digital item that has spatial information tied to it, then you can start to digitize using some type of GIS software, which is what we'll be working on in lab this week. You can go in and a lot of times there's proofing and editing, making sure that the digitizing that you've done is very accurate, and then developing basically that final vector data layer. And so again, that process of digitizing is really getting onto a computer system. And like I said, basically, figuring out what you want to digitize, what you want to create, and essentially going in there and creating points, creating lines for the roads or river systems that you want to be working with, creating polygons for the features that are important for your project. But there are some things to kind of think about when you're doing that. And so as you'll see this week when you start working with this in lab, you're basically going to be creating lines by, the nodes like we talked about, earlier on in the course about sort of how vector data is created in the background. So what you'll be doing is literally creating a point. If you're creating just points, you'll drop points into those locations where you want to and save that information, save those edits. So those points, because there's a spatial reference to the image now, when you create those points in the ArcGIS system or ArcMap system, you're creating points that have spatial information tied to them. So if you're creating lines, you're basically going to create a starting node, right? That first point, we kind of talked about this the first week, and then sort of drawing a line to the next vertex, to the next vertex, to the next vertex, to some ending node, and then kind of double clicking and creating a line segment. So you might be creating one segment at a time, many lines across different roadways or rivers or whatever type of infrastructure you might be looking at. And similar to lines, when you want to create a polygon, you essentially switch in the ArcGIS system, I want to make a polygon, and then you kind of draw that polygon out, creating vertices as you go along, and then completing that polygon at a final spot. And so there's important things to kind of keep in mind. What you'll see in the lab is that, when you're creating lines or polygons, you have to really think about how close you want to be zoomed in to the area that you're, creating these different vector data, and making sure that you include enough vertices. For instance, if you have bends, right, in a river or roadway, for example, you have to really make sure you're creating a lot of different points as you go along, or else you don't get as much accuracy. So that'll be something you start to learn this week as you start working with these data. Now, kind of some errors that you might initially see when you're working with these types of data and digitizing are things like kind of overshooting lines, not connecting the line properly, maybe undershooting. Maybe it's not connecting to the line at all instead of actually crossing over a line. We have something that's called basically a dangling node. That's this idea of sort of going across the line and then having this extra, point out here, this extra node here. So these are really important things to kind of think about as you're digitizing. And so this idea of a pseudo node, maybe not as big of an issue, but maybe you don't want that extra point there because you want to be able to have a full line segment here instead of having an extra one. So a lot of different kind of things to think about, as you're creating digital data. Now, one way to sort of avoid some of these errors, and again, you'll work with that in the lab this week, is the system already has some things in place to help sort of what we call snapping or making sure that anything that's close to the other one will sort of connect together or snap together. So for instance, if you're creating a line up here and you're instead of this undershoot, let's say you're trying to create this line, it's supposed to be right here. If you get close enough to this other point, that point will automatically snap to it. And so these are kind of tools that really help make sure that things are connected together, which is really important for lines and polygons. There's also point snapping. So points that fall, say, within some type of distance to one another would automatically be snapped together and delete one of them out of there. So that might be really important so you're not creating like multiple points in one area, but also ensuring that, if you're within that distance, the points aren't too close together. So there's a whole bunch of different tools like this that you'll start to work with as well, that, again, really help this process of creating points, lines, and polygons. And so just to kind of further explore that a little bit, if you kind of think about this image over here and look at this line, you can see that essentially if there were no rules like this and you were creating, different lines and things out here, things wouldn't necessarily be connected to each other. But if you have these snapping rules, so you see where these circles are here, and basically the rules are saying in this example that if anything that's close within this circle, it will snap together. So you can kind of see what would happen. Let's take this example at first. These 2 points are within, that radius, that area within each other, some type of specified distance. And because of that, the system would automatically snap those nodes together and create just one node here so that you have basically a line being formed. Same with this area here. You can see this node and this line. These types of snapping rules would make that node connect to that line. But you can see this one up here. We got a good connection here because it was within that distance. This one up here is not within some specified distance and therefore just remains kind of out on its own. It's not connected to anything. So like I mentioned, that was just a little bit of information about kind of that process of digitizing, but you'll really start to learn that as you work with it. That's the best way to learn how to digitize. But I just want to remind you, what I mentioned earlier, most maps really are now available digitally, and most of them tend to have the spatial properties already built into them. That's true with most digital data these days, although there are some cases where you find, say, an old digital map or some type of digital image that doesn't have the spatial properties. And again, we'll talk about that in the next video about georeferencing. But for those that do have all that information, you can start to begin with working with them right away as far as digitizing, right? If they have the spatial information, they're already digital, you can just go ahead and start working with them and creating those different types of shape files, those vector data that you want to create for your project. Now, something to think about with, say, digital raster graphics or other types of, say, digital images is those images, when anything's converted to that kind of digital format, kind of like an image that you might take on your camera or something, it is basically going to come as a raster data model because essentially it's pixelated. So if you scan an old image or scan a map into a computer system, it essentially creates an image out of that, a pixelated image, and results in raster data. So we'll talk about that in just a little bit too, and some ways that you can convert basically raster data to vector data if you need to. So just to kind of clarify some of this, some potential steps to digitizing, and then I'll talk about another option instead of digitizing, which is sort of automated process of image classification. But when you're thinking about digitizing, like I mentioned, if you have a hard copy or some old image, in this case, you can see an old aerial image that was taken in 1953. And I'll give an example of this, some old data that I've worked with. We might have a bunch of images. So you can see 1, 2, 3, 4, 5, 6, tons of these images in here. So some of the steps you might have to do is, one, scan all of these different images. I think in this project that I worked on, I had like maybe 40, 50 images that I scanned in. So you scan all those into a computer system, but there's no spatial information. So one of the first things you have to do is georeference those data sets once they're scanned in. Again, we'll talk about that a little bit later on. But another thing you might have to do is, once they're georeferenced and have spatial information, you might also need to mosaic, or essentially combine all of these separate images into one image file. And so you can kind of see that here. These are all a bunch of separate images that were basically converted into one giant image. And that can be really important for another reason, because you might have a study area. In this case, we're looking at Tuckahoe Creek right outside of Richmond, Virginia. So this is a little watershed here. And so you might need all these different images to then basically just what we call clip out that study area, so that you have just the imagery within the area that is important for your study. And so you'll see this in the course quite a bit this year as you're working on like homeworks and some of the other, maybe in some of the labs too. But it's going to be important that when you have a study area, that you learn how to basically use a very simple clipping tool, which is sort of like a cookie cutter that basically just cuts out that area that you want to be working with. And so then once you kind of have this final study area, you've got spatial information, it's in the computer system, it's clipped out, then you can really start that process of going in and drawing out the polygons, or adding points or adding lines, the things that you want to do. And so in this example, if you kind of look at the end result, we have that image here. And that image, after a lot of digitizing, many hours of creating these vector data, basically you end up with a result of a classification. And so in this example, the classification I was doing was just very basic land cover. So like agriculture in the yellow, natural land cover. You can see some of the roads. Again, this was in 1953. So it was mostly agriculture roads, a little bit of houses or businesses. So a little bit of urban area in the black coloring here. A little bit of water here and there. But you can kind of see that, it takes a long time. You have to go into these images and really spend your time drawing out essentially and creating each different line, each different polygon, each different point if you needed point data for some reason. So that's just an example kind of showing a way to use aerial imagery to classify land cover data. Now, to show you just another option of that, instead of actually creating those vector data yourself, there are also options to do kind of image classification. So you can imagine with satellite data, this is the same project that I worked on before. I had a bunch of satellite images around the state of Virginia and the Chesapeake Bay watershed. And again, this little area, you can kind of see a close-up of Richmond, Virginia here. Now, you can take data like this and basically, again, most of the imagery like this or satellite data that's already existing will have spatial references, so you typically don't need to georeference it. But you probably will have to do some similar things. You might have to mosaic, again, combining multiple images into one large image. And again, you might end up having to go through that process of clipping or study area out. So in this example, you can see Tuckahoe Creek watershed overlaid on the satellite data. And I kind of end up with this study area where this watershed, which is this little rivers that drain down into the James River here. So you can see the final clipped satellite image here. Well, basically, there's multiple ways to have a GIS automatically classify imagery. So if you have raster data, like satellite imagery, that has properties to it about the electromagnetic spectrum, and we'll get into this in more detail later, so it's not as important right now, but just kind of be thinking about the fact that each pixel within this raster data set has information tied to it that was collected by the satellite. That's information about the electromagnetic spectrum that was being collected. That information can be used to allow a GIS to automatically classify information. So based on the values within those raster data sets of multiple layers that were collected by the satellite, the system can automatically start to apply, is this area, more related to forest? Is this area more related to urban? Is this area more related to, roadways or things like that? So basically you're using the GIS to automatically do that process of classification for you. Sometimes that process, a lot of times I would say actually, is not solely by the computer. Like you might have the computer set it up and then you go in and do some supervision on it as well. So there's these two different ideas of sort of a supervised or unsupervised classification. But the important thing I would want you to take away from this is that you don't necessarily have to, with certain types of data sets, go in and draw out and do that vectorizing yourself. You can essentially allow the computer system to do it with a little bit of your supervision from the user. And what you end up with is kind of the same idea. So if we look at this 2014 satellite image, the previous example is from 1953. Here we're in 2014. You can see the false color image here, and then the final classification using those same land cover classes. But you can see that you get some pretty nice accuracy as far as where these roadways are, where the urban areas are, where that natural land cover might be, or the agriculture might be. So that's just to give you an idea that there's a couple different ways possibly that you would be developing final, characteristics, final vector data, depending on the initial data sets that you have. But what's important here that I want to point out is with an example like this with satellite data, when you first run this classification system, it's in raster data. And so this data set here would initially be raster data, where each pixel is being classified as a certain type of land cover. So in a lot of cases, what you'll find is it might be very important to convert from raster data to vector data. So for instance, for this project, when I initially did the classification, all of this was pixelated. It was, set up as pixels identifying the land cover class. Then I converted it to vector data, to shape files. And just to have kind of a smoother, remember we say raster is faster, but vector is corrector. This is a great example of that. It's very fast to allow a system to classify imagery in raster data. But what I wanted at the end result was vector data that's more correct, a little bit more accurate. And so again, this is a really important aspect that you'll be working with throughout the course a little bit here and there. Converting from raster to vector data. Sometimes you might need to convert from raster to vector data too. Or I'm sorry, from vector data to raster data as well. Usually I see it the other way around. You usually have a raster data set and you end up wanting to have vector data at the end of it. But there's these tools built into ArcGIS and other GIS, software systems that are basically conversion tools, converting from raster to vector data. And then, so we've kind of talked about hard copy maps, we've talked about digital maps, we've talked about aerial and satellite imagery, some of those sources. But the other kind of source that hopefully will make a lot of sense is just very straightforward, collecting things directly from like a GPS unit and then entering in latitude and longitude into point data that you create, adding data into attribute tables. So you already have spatial information, but there's other things that are tied to those locations from, say other sources of tabular data that you have. There's ways to essentially join those data together, add those data, or go in and create them, right off the bat by sort of adding a field and manually entering in information into the attribute table. So there's a lot of different ways to sort of directly either enter data into, shapefile, vector data, or ways to take other data sets of information that has some type of common thread and essentially joining those data to the attribute tables. And we'll talk more about that later on in the course about how to join data. So hopefully, if you're thinking about this, all of this should hopefully make sense now. You might have to scan image, you might have to scan hard copies to make it a digital image. You might have to georeference data, which we'll talk about in the next video. But once you basically have digital data, and that digital data has spatial properties, a coordinate system tied to it, then you can use those data sets to digitize and basically create a final vector data layer. And so I hope all of that makes sense. I think as you work through the lab this week, you'll really start to get a feel of the process of digitizing and the amount of work it potentially can take to digitize data. But hopefully this will give you a really good understanding of basically how digitizing works and some of those important data sources you might be working with down the road. But that is going to be the end of this video. And again, in the next video, we'll really dig in and start talking about this idea of georeferencing.